According to Nabil Hassan Al-Kumaim et al. 2021, the university as a key higher education institution is one of the most important organizations to deal with the COVID-19 pandemic, as it is one of the most important service sectors and students represent the potential future workforce. During the MCO period, online education is a safe and practical way to continue the supply of education for students and educators. As for Mohammadi Shuka et al. 2020, promoting healthy eating among university students has become an important public health and research priority because the incidence of obesity and overweight among adolescents continues to increase and tends to persist into adulthood. Obesity is one of the health problems caused by a person's inability to maintain a consistent eating patterns. Linear programming (LP) was used in this problem as a technique for solving optimization problems, which involve the optimization of a linear objective function subject to the linear equality or inequality constraints of decision variables according to Abulmark 2018. In the diet problem, the cost is set as the objective function and the constraints are the minimum requirement of nutrient intake.
According to the Centers for Disease Control and Prevention 2017, obesity is one of the health issues caused by the behavior of a person who does not maintain an eating pattern. During the pandemic, students are forced to change their nutrition due to a lack of food while participating in online learning. Students in higher education require more funds to cover the cost of study and living in universities, as higher education costs in both public and private educational institutions rise. Nur Haslinda Daud, Nur Liamat Norwani, and Rohaila Yusuf 2018. Many have the conception that a healthy diet is expensive, but the truth is, it is not. We need to choose the correct menus and diet. Therefore, we choose a topic related to food care because university students need to maintain a healthy eating pattern throughout ODL. Hence, the research is done to minimize the cost of food, a more nutritious and balanced diet pattern during MCO.
Objective. The objective of this study is to minimize the cost of daily serving and to ensure students to receive a balanced diet in a set of food according to the nutritional requirement. Significance of project. The significance of the study is to ensure the university students who are involved in online learning taking enough or correct amount of nutrition in their daily meals. This is because food is the source of nutrition and provide energy to carry out their daily routine. Next, the significance of this project is to make sure the cost of healthy diet is at minimum cost for university students. As university students are not working and does not have a stable source of income, they need to make sure the cost for their healthy diet is the minimum. According to Ruslan and Muhammad 2021, the cost for set of food can be minimized if the university student can identify the food that have enough nutrition in their daily meals.
Next is literature review. In this part, there are three parts which are linear programming, diet problems, and students' dietary patterns during ODL. Linear programming. According to Afizah Baki, Siti Madiha Mangso, and Khairi Razak 2019, linear programming LP is a well-known method in solving many minimization or maximization problems. One of the latest studies were conducted by Afizah Baki, Siti Madiha Mangso, and Khairi Razak 2019, which use LP to determine the minimum cost for a balanced diet. In diet problem, constraints for LP typically regulate the intake of calories, macronutrients, and micronutrients. Second is diet problem. Diet is simply the sum of the foods you consume, which provides what the body requires, and it has a significant impact on how an individual functions physically, rationally, and even socially. Nutrition is the most important aspect of overall health because too much or too little nutrient intake may result to an unhealthy habits and further consequence. College weight gain is likely during the transition into the university life, which is a critical period when young adults' behavior, including dietary habits, are conducive to change as they gain independence in making food choice. University students are at a higher risk of developing unhealthy eating behaviors with inadequate nutrient intake gain et al. 2011. Some of these behavior include irregular meals, not eating breakfast, reduced fruit and vegetable intake, and increased consumption of fried food. Third is students' dietary patterns during ODL. Online distance learning, commonly mentioned as ODL, has been the way in implementing learning sessions for school, college, and university students since the early time of movement control order announcement. According to Si Hui Cheng and Muhammad Kamil 2020, the result of studies related to the relationship of stress to the eating habits of university students shows that the stress makes them eat less than people who are not stressed. Unhealthy or unbalanced diet styles that students inadvertently practice may cause their weak immune system and vulnerable to disease such as diabetes, hypertension, and heart failure. According to Isra Asaf et al. 2019, a healthy diet pattern followed by daily exercise helps a lot in an individual's achievement, wellness, confidence level, and reduce the likelihood of getting stressed while studying.
Methodology explained the detailed process of how this project were done truly to achieve the objective. In order to obtain most preferred menu of female university student, a simple survey was done using Google Form and were distributed to sample through WhatsApp. The sample of this project are 30 Bachelor of Mathematics Education with Honour, Cohort A181, Sultan Idris Education University female student only. The first section of the survey consists of 2 questions regarding student personal information, and the second section of the survey consists of 12 questions related to their diet before and during ODL, and the cost spent on their daily meals. In this survey, we included the price of each menu as in this diagram on the left, so sample can choose their preferred menu while taking their budget into account. The data obtained from the survey shows that the top 3 preferred menu are boiled egg, nasi lemak, and cake. Therefore, the 3 decision variables are x1, x2, and x3, which are number of daily serving of boiled egg, nasi lemak, and cake respectively. According to Amidor, MS, RD, and CDN 2013, 3 balanced meals a day is a healthy diet pattern set by nutrition expert. The price or cost of each menu are the coefficient of objective function of the LP model that were formed. The table on the right shows the recommended daily intake of nutrient for women aged 18 to 29 years old according to Ministry of Health Malaysia 2017. This limitation represents the limitation of 4 constraints of the LP model. The amount of carbohydrates, proteins, fats, and calories in each menu were obtained from MyFitnessPal 2022 to complete the coefficient of each decision variables in the constraint of the LP problem. Therefore, the standard LP model formed in this project is minimize Z equal to x1 plus 3.5x2 plus 3.5x3 subjected to 4 constraints, which is 0.5x1 plus 58.2x2 plus 66.9x3 is greater or equal to 50, and the second constraint is 5.5x1 plus 9.7x2 plus 0x3 is greater or equal to 53, and the third constraint is 4.7x1 plus 13.1x2 plus 11.9x3 is greater or equal to 51, and the last constraint is 68x1 plus 400x2 plus 370x3 is greater or equal to 1840, and the restricted constraint is x1, x2, and x3 must be greater or equal to 0. The first constraint of this LP model represents the constraint for carbohydrates, the second constraint represents the constraint for protein, the third constraint represents the constraint for fats, and the last constraint represents the constraint for calories. The LP problems were solved using Linear Interactive and Discrete Optimizer, that is LINDO, software 12, using the LP model that has been set for this diet problem.
Results. The following solution is in report window. First, 16.98130 is the Z value. Next, here we have 3 variables. X1 is boiled egg, X2 is nasi lemak, and X3 is cake. This table shows the minimum cost needed by the students for balanced diet. So for x1 boiled egg, which they need 2.176058. x2 nasi lemak, they need 4.230070. x3 cake is 0. Reduced cost. Here we have the reduced cost for cake is 1.206115, which means if the students take one slice of cake, then they will lose Rm 1 ringgit 21 cents. Thus, the cost no longer minimum. Next, we will move to the dual price. Row 1 is dual price for carbohydrate, row 2 is dual price for protein, row 3 is the dual price for fat. Here the dual price for carbohydrate and protein are 0, since it already surpassed the carbohydrate and fat needed by 197.28 and 14.64. Thus, the surplus variable slack 2, which is equals to S1 197.278107, and slack 4, which is equals to S3 is 14.641392, and in the optimal solution. The dual price for the protein is negative 0.105167. Next, we move to the sensitivity analysis, where if we change the menu price, it will impact the optimal solution. Now, we first look at the objective coefficient ranges. The current coefficient for x1, which is boiled egg, is 1. The allowable increase in price for boiled egg is 0.984536, while the allowable decrease in price for boiled egg is 0.405. Next, the current coefficient for nasi lemak is 3.5. The allowable increase in price is 0.912973, and allowable decrease in price is 1.7363 and 64. Next is for the cake, x3. The current coefficient is 3.5. So the allowable increase in price is infinity, and the allowable decrease in price is 1.206115. Next, we will move on to the right hand side ranges for each constraint value. Row 1, carbohydrate, where the current right hand side value is 50 gram. The allowable increase in is 197.278107, and the allowable decrease is infinity. For row 2 is protein, where the current right hand side value is 53 gram, and the allowable increase is 80.872688, and allowable decrease is 8.379999. Next is the fat. Okay, the current right hand side value for fat is 51 gram, while the allowable increase is 14.641392 gram, and allowable decrease is infinity. The row 4 is for calorie. The current right hand side value is 1840, and the allowable increase is 345.566986, and the allowable decrease is 852.365845. Lastly, the tabular section. Here, the odd terms refers to Z. The basic variable for this problem are x1 in row 4, x2 in row 2, and slack 2 in row 1, and slack 4 in row 3. However, notice that the right hand side constant is in row 0 is negative 16.98. The negative sign on the right hand side value is the result of Windows software automatically changing a minimization problem to a maximization problem. Thus, in the final report, the negative sign must be reversed, which the program performs automatically. The non-basic variable coefficient for this problem are x3, slack 3 and slack 5, and all of these values are seen to be positive value. The Lindo output gives all of the variables in positive value, which can be considered non-positive values since the problem is to minimize. This row 0 is in the optimal tableau is multiplied by negative 1 to show more clearly the true value. Then, since all the BVs for this problem also have 0 coefficient in row 0 of our row, and there are no NBVs that have 0 coefficient in the same row. Thus, this LP problem has a unique optimal solution, and indicating that the solution or output obtained was indeed the final tableau. Discussion. Based on the problem, which is to minimize the cost to maintain or improve a healthy diet lifestyle among university students during online distance learning, A formulated LP problem has been made and solved using classic Windows software. The result shows that 16 ringgit 98 cent is the minimum cost needed for a student to get a balanced diet during ODL. This cost involved 2.18 boiled eggs, 4.23 packs of nasi lemak, and 0 slice of cake. These recommendations allow a student to get enough nutrients in a day and still able to minimize their costs. But if the student still wants to take a one slice of cake, it can cause a loss of 1 ringgit 21 cents each time of an addition of cake is made, and the cost is no longer minimum. The dual price for protein is negative 0.11, which means the cost to maintain a healthy diet will increase by 11 cents for every unit increase in the protein nutrient needed. Similarly, the cost increase by 0.1 cents is associated with the increase of a unit of calories nutrient required. The fact that the dual price for carbohydrate and fat are zero is due to the fact that the ideal menu already surpassed the carbohydrate and fat needed by 197.28 and 14.64. Those are the surplus variable slack 2, which is equals to S1 197.28 and slack 4, which is equals to S3 14.64 in the optimal solution. Then, sensitivity analysis also shows that a change in menu prices can impact the optimal solution. For example, the maximum price for the boiled egg that can be increased is 98 cents and the maximum reduced price for the boiled egg is 41 cents. If the change in spending made by the student is still within the range, the values for the solution will be the same. However, any changes outside of this price can change the optimal solutions. However, even though the solution obtained after some changes made in right hand side amount is feasible, there is possible for the value of boiled egg, nasi lemak and cake to change. In addition, any changes made outside the range obtained on the right hand side range will make the current solution no longer feasible. So a new optimal solution for the problem needs to be calculated.
So conclusion. In conclusion, the optimal solution for the problem are x1 is equals to 2.18, x2 is 4.23 and x3 is 0, where the x1 is boiled egg, x2 is nasi lemak and x3 is slices of cake. These findings ensure the students to receive a balanced diet in a set of foods according to the nutritional requirements and still able to minimize the cost. The optimizations were successful in identifying formulations that met all the constraints. As a result, this solution can assist university students in budgeting their expenses while providing the nutrition their body and mind requires.